Welcome to this video that will cover some of the coding activities that are within the 01 Jupyter Lecture Notebook. So in this video, I will go over this first activity involving creating markdown and code cells. I will also go over the activity making code readable and playing with the order of code execution. I will not go over these two activities as they are rather personal to you and just require doing stuff in Markdown, but I will show the tech activity because that is probably a very challenging one as you're first learning this material. So go ahead and click here so that I can be sent. Oops, let me close that. There we go. So I can be sent to this cell. So activity, creating Markdown in code cells. So the first step is to create a Markdown cell directly below this cell. In other words, before the next Markdown cell, and put in some text in a list format with bullet points with some italicized, bold-faced, and strike-through fonts. So that's the first instruction, the first step. The second one is to create a code cell directly below that Markdown cell and before the next Markdown cell that contains this cyan borderline. See, I have this thing here. Your cell should come before this cell right here that's selected. And that should compute 7 times 5 and execute that cell. So I'm going to go ahead and on my keyboard, since this cell is selected, I'm going to press A. Similarly, if I was here, I could press B on my keyboard and that would create a cell below. The A creates a cell above where I'm at. The default code cell that's created is always a code cell. You can change it here to Markdown or code depending on what you need. So here I know I need to have a Markdown and then a code cell. So I've already at least created these. And you could also, I believe here, create cells. So let's see, I believe it's, where is actually, no, I'm sorry, it's right here. This is where you would be creating cells. So there you go. See, that creates cells automatically. And if I want to remove them, you can always press that key right there. That looks like a scissors, or press the X key to cut it out as well. So, all right, I have my Markdown cell and I have my code cell. Now for the list format with bullets, what I'm saying is you should have, like something in, this first item of your list, and then put something else here, and then another thing. Your list can have multiple things, but if you do it in that type of format, you'll notice there's my bullet point list. Now, of course, this does not have the type of fonts that I'm asked to do here. So you can always just, if you forgot how to do this, if you weren't following along with what I was suggesting to do in the video, you can always open this up and see how I made an italicized with asterisks around the words that I want to italicize, 2 asterisks on either side for a boldface, and then a couple of the tildes to make strike-through fonts. So you can look at that and then say, okay, well, this is what I need. I need to have, some sort of italicized text, and then maybe some bold-faced text. And you can just, however many words you want. You can also do bold-faced italicized with 3 asterisks if you like. And then, of course, another thing. And let's go ahead and, that's just, there you go. So I have all these different types of fonts. So you could do something like that as you're learning Markdown. Put whatever you want. I really recommend you try your own things. Try lots of different, list formats. You can also do sublists. All you need to do for that is put some indenting. 2 spaces is sufficient. And this is a part of a sublist. And here is another part. And there you go. See how that also has bullet points, but they're a different style. These are kind of circles, and then those are squares. So that's accomplishing that first part of the activity. I just want you to get used to Markdown. And then the code cell below, you're supposed to compute 7 times 5. So, all right. We've accomplished our first activity. So we'll just go ahead and move on to the next activity, which is about making code readable. The first instruction is to add a blank line to separate the 2 lines of code. So let's go ahead and do that here. That's what I mean. Add a blank line. Just to show that again, I put my cursor here and I press enter. That's it. Or return, whatever your keyboard equivalent is on your computer. And that now has a blank line to separate the 2 lines of code. And it's just a little easier to read instead of having them like that. It's just a little easier to read. Add some code comments to the cell. The proper code comment commenting format is to do 2 spaces. So 1, 2, put the pound sign, do then another space and say what it is. So this assigns the value of 2 to the variable x, something like that, something useful. And I said some comments to the code. So this is one comment, right? It's not comments, it's plural, so there should be 2. So 1, 2, and a pound sign, or maybe you call it a hashtag. And then this adds 3 to x, but does not assign the output to anything. So there you go. And then after you've added these code comments or something like these, I say create a markdown cell below this code cell. So I'm in edit mode now, that's why it's blue. If I notice this has selected this blue outline around this code cell, but if I click over here, it's not. And so now I can press B on my keyboard to create a code cell below this, or if I come here, I can press A to create a code cell above. So I'll do it that way. I pressed A on my keyboard, and then to switch to markdown, I'm going to use a hotkey. I'm going to press the M key on my keyboard because I'm not in edit mode. And notice this switch to markdown up here. But you can also do the drag down menu, but as you start to use the keyboard, it will make more sense. So now all you're supposed to do is explain the output of the code cell. So of course that means run the code cell. Notice the output is 5. So what did this code cell do? Well, this is for you to write, but I'm not going to type everything in for the markdown. I'm really just trying to show the code. 2 was assigned to the value to the variable x, and then 3 was added to it, which produced an output of 5 from that operation. That's what happened. So you can write something to that effect. Okie dokie. So now playing with the order of execution. Here I say go back to the code cell where x is declared. Copy and paste the contents into the code cell below. So where was x declared? Right here. So let's copy and paste that. So I did Control C to copy all that. I pasted here, and now I want to split the code into 2 separate code cells, each with a single line of code. So I just put my cursor here to right between these 2 lines. I can go to Edit, and I can go to Split Cell. Notice there's some hotkeys, Control Shift and a minus, but I often forget that that's what it is for split cell, so now I split it. So x equals 2, x plus 3, now they're in 2 code cells. That I've accomplished the first two parts of the activity. Now I ask you to change x equals 2 to something else. Execute it, and then execute the code cell above with y equals 3 times x plus 1 again. The idea was that you had run this already, of course, as you're working through the notebook linearly in a top-down fashion. So now I'm saying, well, maybe change x equals 2 to, let's say, x equals 7. It doesn't really matter. You should, whatever you do, though, you should probably update the code comment so this doesn't read 2. So now I maybe say 7. And so now, when I run this, if x is 7, then y equals 3 times 7 plus 1 should be 21 plus 1, 22. That's exactly what happens. So this is just, notice, this code cell is above this code cell. But I ran it after. See this 5 right here? It was executed after I ran this. This is the order of execution in a notebook. It's very easy to mess things up because if you don't work in a top-down fashion and you go and you change something down here and then you run things up here and there's similar variables being used, you can get some outputs that maybe don't make sense if you look at this and say, well, geez, if I'm reading it, x equals 2, and then 3 times 2 plus 1 should be 7, but it's 22. Why is that? Well, here's a 2, because that's like this was the second code cell to be executed. And here's a 5, so it's like, oh, this was the 5th code cell executed. Well, this was the 4th, because originally it went 2, 3, 4, and then I went and reran this, and then it became the 5th. So that's just to get you understanding a little bit about the importance of the order of execution in the notebooks. So that's it for that activity. These are activities that you really have to do for yourself. You're just getting more practice with Markdown and creating lists, because I will ask you to explain a lot of things in class using lists and Markdown cells. So then the tech problem, you're supposed to tech yourself, but I'll go ahead and show you how to do this. You're supposed to use tech to typeset Stirling's approximation, the more precise variant formula according to Wikipedia, using at least 2 of the above format options. So I'll go ahead and do it, let's say, with format 1 and format 2. First, I need to go to the web page, so I'll just pause the video for a second and open that up. All right, so I've now opened up on my web browser the tabs for both parts A and part B that using Wikipedia. So let's go ahead and look at Stirling's approximation. So here is Stirling's approximation. And if you read through the first part of this, what you'll find is that if you get to this part and it says yielding the more precise formula. So this is what I was referring to, the more precise formula, right? I said the more precise formula. So you just have to read the instructions carefully. So it needs to be in factorial, asymptotically, the square root of 2 pi n times the fraction n divided by e raised to the n power. So what I need to do here, like this is where your answer goes to part A, and I want to use, let's say, a format 1. So I'll just go ahead here and just copy this over. So format 1. And put this here, and then this is Stirling's approximation. The more precise formula is given by, and then I'll just go ahead and put what that formula is here instead of the previous one, and I'll just go ahead and kind of remove this part. Well, some of this is useful, but I'll just go ahead and get that. So it's n factorial, and then that is the symbol that you need to produce a tilde in tech. And then I have the square root of 2 pi times n. So this will be square root. And now notice I do curly brackets. Everything I put in the curly brackets will be under the square root sign. Pi is a Greek letter, so I have to use that backslash pi. And then n. If you do this, if you just do that, let's look at it. Notice it's in red because it's not rendering correctly, because you need to put a space between the pi and the n, because that backslash pi is supposed to be a Greek letter. It needs to be by itself so it knows to render it correctly. So there's your square root of 2 pi n. Now what I need is to multiply by the fraction n divided by e with parentheses around it raised to the n power. So that is simply given by left and right. So that will auto size the parentheses here and here. If I don't have here, what I'll first do is get rid of the left and right command and show you what happens when I put in the fraction. So in the first curly brackets will be the numerator, and the second curly brackets will be the denominator, and it's n and e. Now look what happens. See that the parentheses and the size of that, the n over e, doesn't quite look right. If I make this, I think it's not sized correctly. In my opinion, I think this should do an auto sizing. And then notice those parentheses are a little bit bigger, looks a little bit better there. And then I need to raise it to the n power. And then what you need to say is, okay, where e is Euler's number, and then what is n supposed to be, right? This is just some value. Pi is pi, which is actually, pi is like this. I'll just go ahead and grab this. That's, you're supposed to say what each of these pieces is. So there's pi, and n, of course, is what you're evaluating. So this is just what you're just doing is approximating, is the value that you're approximating the factorial of. So n is, and let's put it in there. So n is the value we wish to approximate the factorial of using Stirling's approximation. So that's pretty much it for like format 1. This is in line with the bullet list. I am not going to do format 2 or format 3 actually. I think at this point you can see how to adjust these. You can just kind of copy and paste and edit as necessary. If you put this in line, so I'll just do that like, or excuse me, not in line, but in a display math, you'll want to have the comma there, something like that. So that would be like a format 2. It would look like that. Now I think that looks better because it sizes the fraction better. So, some of these are just stylistic choices. I'm just pressing Control Z to undo. But you're supposed to provide 2 formats. I just want you to get some practice. So that's like format 1. Let's look at how to typeset both the differential equation for population growth as well as the solution to this differential equation, which can be found on this page, which I've already linked to here in this logistic function. So here's the differential equation. You can see, you can just read right here. The differential equation is this, and then here's the solution. And it's written 2 ways. The solution, you only need to tech one of these I would probably check this one because it's just easier. Having fractions inside of fractions is usually going to lead to some errors and just typos. So I'll just type this solution and that. And I'm not going to do the bullet point list to describe all the terms, like what P is, what R is, what K is, what P naught is, what E is, and what T is, right? And what dP dt represents. Like you should have bullet lists that say what all of the terms are. Just so you're getting, again, more practice making lists and doing tech. But I'm just going to show you how to do the formulas because those are going to be the more challenging parts. So let's do this formula right here for the differential equation. So I'm just going to go ahead and I'm just going to do it in a display math, which I like to do it like this. So I have my dp dt, and this is equal to, already forgot it, r times p and times the, in parentheses, 1 minus p over k. So r times p, and again here I'm going to do this. I'm going to put a parenthesis without the left or right commands here. So 1 minus fraction p divided by k, right, where k is the carrying capacity. So that rp times 1 minus p over k in parentheses. Now let's just go ahead and look at this. There you go. See how the parentheses are not sized correctly? They're not, because of this fraction is bigger. This is why I always recommend using left and right as the general, oops, should type it correctly. There we go. Now the parentheses are sized correctly. So there's the differential equation. It's not that hard. You get that part out. Again, you should say, you know, what it is, like the differential equation for population growth is given by, and you write this, and then you should have your bullet list, like, you know, you say where. So I put like a comma here grammatically, where, and then say what P is, what R is, what K is, and what dP dt represents. It's the derivative of the population with respect to time. So you should have that as bullet points. I'm not, again, going to do that. That's just something for you to be able to do. I think this is the hardest part, is getting that formula right. Let's go ahead and look at the solution. P of t, so t is time, is equal to the carrying capacity times the initial population, that's P naught, e to the RT divided by k plus P naught e to the RT minus 1. So let's go ahead and start writing that. So the solution to this differential equation is given by, I think this again looks best this way, P of t, pardon me for 1 second. Just had to pause the video because my son was just kind of having a lot of laughter in the background. P of t equals, I've already forgotten, this fraction here. So let's just go ahead and put the fraction environment together. So the fraction, and we'll have the numerator goes in this first set of curly brackets, and the denominator will go in the second set. So in that first set, the numerator is k p naught e to the RT. So k p subscript 0, so do the underscore with a 0, e2, it's raised to the power r times t. Now if there's multiple things in that you're raising to a power putting in a subscript, you need to put your curly brackets again there and have rt. If you don't have that, so let me just put like a 1 there for now. So notice this is k p naught e to the RT. If you fail to put curly brackets here and you just have it like that, notice it doesn't display correctly. It's e raised to the r and it looks like it's times t. So it's really important to group things together in superscripts, subscripts, and various places. Just like we're grouping things under square roots or in fractions and numerators and denominators, we're using curly brackets. So there's our e to the RT. And again, you see that looks correct, e to the RT. Now we just have to get the denominator correct. And the denominator is k plus p naught times e to the RT minus 1. So let's go ahead and do that. K plus p naught, and I already forgot again this thing, k times, because p naught times e to the RT minus 1. So here again you could go left and right, and any left needs to have a right. If you put a left here and you don't put a right here, let's try that and I'll show you what happens. 1 minus e to the RT, I believe, again in the, e to the RT minus 1, excuse me, I got it backwards. E to the RT minus 1. Now again, I have this left command here, and you can always put spaces. The spaces are basically ignored when you do the tech. It just makes it easier to read, perhaps. So I can put spaces between a lot of things if it makes it easier for you to read on the screen. So I'll just go ahead and do that. So again, I have a left here, but it's not followed by a right. So if I look at this, notice you get something like this. It's because you don't have it correct. You have some missing component. So in this case, I'm missing the right. There you go. So there's my solution to the differential equation. And again, you should say like where, and then again have like your list, like what is P, what is K, R, and so on. Some of it will be redundant from here, or if you put it all in the same cell, maybe you don't want to repeat. Just only say anything that's new in this that wasn't present here, which in this case would be the P naught, P sub 0. That wasn't present in this differential equation. So at any rate, that's it. That's all I'm going to show in this video. I've done kind of all the coding and the harder tech stuff. And thanks for listening. I'll be talking to you in some future videos.